Okay, in the last video we went over how to properly set up our Blender scene to be able to render out our animations. So let's take a look at rendering that out. Alright, so since the last video I've updated a couple of things. Mainly I've just changed the color of this sphere back to green. In the last video I accidentally made it the background material, so I've just updated this to a green material. Also, I just needed to mention that we need to be using Blender 2.92, which is the latest release. They've made some adjustments to the crypto mats, which in previous versions it wasn't being rendered out correctly. The metadata wasn't being brought over. And finally, to render out the AOVs correctly, in 2.92 they've actually updated it, so you need to have an actual material. You need a material output node, and I've just put just a black diffuse in there, so that way it renders out correctly. If you don't have this, the alpha will be black and the passes won't render out. And one last thing that I actually want to change is we're going to turn off the surface color inside all of the light passes. And turn it on in the beauty pass. The reason being that, as I said in the last video, this is going to be the beauty pass is going to have everything that's uniform across all the shots. So the surface color isn't going to change based on what light is hitting it. So we'll put it into the beauty pass. That way we only need to render it once rather than 3 times. And with that, we can now jump into the compositing tab. Once we render something, we'll get an output here, and then we can have our node graph over here. So let's render out just a single frame, just so we can double check exactly what we've rendered, and then we can actually see what we're doing here. Okay, so now we can actually see what we've been rendering out, which is a good thing. The typical way that people export things from Blender is through here. They'll change this output and change everything here, but we can't actually render all our view layers at once doing this. So we actually need to use first of all, let me put on this so you can see what I'm pressing. So we need a file output node. The reason for using this is there's a couple of reasons. One, we can have multiple of them, so we can render out multiple view layers at once. And secondly, we can change the properties in here. Firstly, to be using OpenEXR multilayer, and now we can add all our layers that we need in here. Also, for rendering out the image, because I'll be moving into nuke, I need to rename this to RGBA, so that way nuke knows what it is. Another thing we need to do to the image is to denoise it. So we'll use the standard denoise node, and we'll just plug these denoising data into here, and that way, instead of the image looking like this, we can send it to nuke looking like this. So the next thing we need is our surface color. And we can plug that in. Then we have our 3 cryptomat objects. Now we want to keep the names exactly the same. It's sort of just the safest option. And this is what's been updated with Blender 2.92. So if we keep this exactly the same, it'll transfer to nuke correctly. If this doesn't work, a fix that some people have been using is by you put any node in between here. It doesn't matter, so just putting a reroute in there works, and that should hopefully fix the problem. But also keeping the name the same. You can update the name as long as you have these 2 zeros at the end, and it should work fine inside of nuke. The next one we want is our noisy image. Even though we're denoising, if the denoise looks kind of a bit shoddy, that way we can sort of easily revert back to our noisy image and then do whatever we want with that. Whether we want to denoise it again in something like neat video or something, we can do that later on. So now we want to set a file path where we want this to be rendered. So if we put 2 dashes, that's going to make sure that our file is saved in the same directory that our blend file is saved in. That's what the double slashes mean. Then we're going to put it into a renders folder. I've done this a couple of times, so I'm going to use the version 3, and then a beauty folder. And then we want to actually name our file, so we'll call this beauty underscore version 3 underscore, and then Blender will fill in the frame number .exr, which is why we need that final underscore there. So for Blender to render the other view layers, it needs to have the instance of the view layer inside the compositor. So if we put in another render layers node here, and we change this to data, we can have a look at this, and it should be black when it wants to update. But we can see that all our passes are in here. But we want to put this into this beauty render here. So if we add our 3 inputs here for PW, PO, and PC, we can plug these straight into here. So now these 2 render layers will be exported to the same file. So now we want to do the same thing for each of our lights. First one we can do is environment. We want to denoise this also. So running it through the same thing. Again, changing this to RGBA so nuke understands it. And then we want our diffuse direct, indirect, and our glossy direct, indirect, and our noisy image to be coming out of here as well. So we want our diffuse direct, and you can name these sort of whatever you want, whatever you feel comfortable using. You can put in here. So I prefer calling it reflection. It just makes more sense to me. So that's what I'm gonna put in. And the last one is noisy image. And then we just plug all these in the same way. And once again, setting the file name. This time using environment version 3, and also making sure that we set this to OpenEXR multi-layer, and that has reset my names. So let's do this one more time. Okay, so now we just want to go through and do this again for the other two lights. This time it's a bit easier because we can just copy this down here. Okay, so now that we have this set up, you can either press Control F12 or come up here and say render animation. Okay, so that took about an hour to do. It's like 50 minutes to render. So we're going to get rid of the still frames, and we will just double check that this has a bunch of frames in. Let's bring in these four. Press L to line these up. So we have our beauty, which now has an animation. As do all the rest of them. So the way we're going to set it up is fairly specific. I have my beauty on the left, and then I put my environment, key, and fill on the right. And we are now going to merge these three together using a plus operation, making sure this is set to union. And let's do the same for the other two. So now this beauty pass should match these three plus together exactly, which it does. Now, setting it up this way, just in case, say I don't need to make any changes here, I like to put a switch underneath and plug these in. So if I'm not making any adjustments to my individual lights, I'll just keep the switch to run into my beauty. It'll be a lot quicker that way. But if I do end up making any changes over here, then I will switch it to this one. So the reason we have split them up into the individual lights is to give us the most amount of control possible. So let's say we think we're looking here, our key light maybe it's a bit too bright. If we can chuck in an exposure, and let's say drop it by 0.3 of a stop. So now we can see that our key light has been brought down by that much. Now if we didn't render it out this way, we would have to go back into Blender, drop this light down a third of a stop, and then re-render, which would take another hour to do, versus right now it took us 5 seconds. So another thing we can do, other than just changing the intensity of the light, we can actually go in and change the color of the light. So we give ourselves a bit more room. Using a shuffle node, we can actually grab the direct diffuse, which is the first hit of light that's coming off the actual light source. And to change the color, we want to do that over here. But first we need to remove it from this pass. So we can do that with a from merge, which is basically saying we're going to take this away from this. So now if we look here, we're removing that light. The rest of what's in here is the indirect, so it's whatever's bouncing off the floor or off the other objects. So to change this, we can just put in a grade node, and I don't know, let's say we want to make it more blue. Push it more blue, get rid of some of the green. And then to put it back in, we want to do the opposite, so we've minused here, so we want to plus underneath. So now you can see that we've taken this green direct light and made it more blue. But obviously we can see we still have this other green. So we can do the same thing, but this time using the indirect. Just copy the same thing. Remove it from the render. And then plus it back on top. Like that. So now we've changed this color to be blue, which obviously it took far less than an hour to redo this or make this change versus doing it again in Blender. We now have a blue key light. So we're able to change the light colors. Another thing we can do is we can go in and change the object colors. And to do that, obviously we don't want to do it on each of these 3 passes individually, because we're just repeating the same work over and over again. So we'll do it underneath this switch node. And we don't want to affect the lights, so if we put in another shuffle and plug that into our beauty render, we can come in and grab the surface color. So this has no lighting information in it whatsoever, and we can use that to change the color of our objects. Now, as with the light, we want to remove this color information from our render before we make a change. However, when making a change to the surface color, we actually want to divide the surface color by the render, which you'll see that we now just have our lighting information coming in here, and all our surface color information is coming over here. So now we can make a change over here. We'll say we'll make it more red, so that we can make this, we're going to make this cube red, or maybe we'll make this red. It'll be easier to sort of push that one around. And then again, we want to do the opposite of this operation again underneath. So the opposite of a divide will be a multiply. So we want to multiply that color with the lighting information. Now we can see that we've made that change, and our ball is now a sort of pinky red, but so is everything else, which we don't want. So we want to restrict this grade to just this ball. And in the olden days, I guess we could use a rotor. You can go through and animate this, or you could pull a key on the ball. But we did render crypto mats for a reason. This node doesn't come standard inside of Nuke, but I'll leave a link in the description where you can download it. Pretty much every company will have this node in their system, because everyone uses crypto mats. So we can just plug that into the mask, and you'll see that now nothing is being affected by this grade. But if we look at this crypto mat node, so once we're in here, if we select our picker add, if we hold Control and Alt and click on one of these objects, you can see it turns bright yellow, and in the alpha it'll be white where that selection is. We can go through and select multiple if we want. Clear it. We can do single selections, so it just selects a single one, which is what we want. It doesn't really matter if we have it on or not, but we're just wanting to affect this ball. So now that we have this alpha here, if we look at the grade, you can see that now it's only affecting that ball. And if we look between these two, now our ball is pink. Now there are still problems. Obviously the bounce light is still bouncing off green, which you can go in and fix. But if we were doing a much more subtle change, it's probably not gonna matter as much. Anything sort of super drastic, maybe you have to weigh up your options whether you want to go back into Blender or do it this way. So another one of the passes that we rendered out, or 3 of them, were our position passes. And one of the ways that we can use those is by using a Z defocus. So that way we can defocus our image. So we want to be using our PC pass for this. So this is, instead of using a Z depth pass, we can use our PC blue pass. And we need to change our maths to direct, because the way the PC pass works in the blue channel is it's using sort of real world values. So I think if we actually have a look at the PC pass, if we have a look at the blue channel and pull this down, we can see here this sphere here is 12. There's a value of 12, which means that it's 12 meters away, whereas this cube back here is 21 meters away. So Blender can use that information directly by setting that in here. And if we say set the focal point to this, we always want our size to be set to 1 if we want sort of real world accuracy. Now you can see that ball is in focus, and the cube goes out of focus. This ball here slightly goes out of focus. I'm not a massive fan of the Z defocus. I use there's a node that I downloaded from Nukepedia, which simulates actual camera. So from Blender, the camera that we rendered out, the focal length was 50 and the aperture was 35, I believe. And the focus distance of this ball is 12. So if we put that there, and changing our depth pass from the Z depth, now that should fix it up. So now this will be sort of real world accurate. We can also do things like using P maps. So it's a position map. If we plug this in over here and we use our PW pass, you can see that we can actually use the picker. We can sort of select different parts of this image. Using the PW pass, it'll stick to wherever it is in the world space. If we use a PC pass, it will move with the camera. So if the camera now pushes in, this will sort of move backwards along with the camera. I mean, it will look like it's staying in the same spot, but it moves relative to the camera. And then we also have position object, which, if we make this much smaller, we can see that it's going to stick to this object. So if we go sort of forward and backwards, you see it's going to stay on that exact same spot on that object. One drawback which we can't really get around is that it's going to be the same. It's going to add it onto all your objects because the data is the same as we saw in the render. But then you could use that with a P map, crypto map. So that way you just limit it. Instead of getting everything, you're just limiting it to one object. I think the final thing that I'll sort of show is a node called position to points. If we plug this in here and have a look at this node, it'll throw us into the 3D viewport. And if we select our PW pass, you'll see that we get a point cloud, which is going to relate to what we rendered. Now Blender, its 3D viewport has Z is going upwards, whereas nuke has it has Y going upwards, so that's a bit of a problem. But I wrote something that will switch the world of the position pass around. So if we want to switch the PW pass, which is what we're using here, instead of Y being up, which is the default in Blender, in Nuke, we can switch it to Z being up. So now our position pass is correct. This is fairly useful in case you want to so you want to place a card on a specific point inside of 3D space here. So you want a card right at the front of this cube. You can go into this in here, and then you can put a card in. Let's make it a bit bigger. Let's rotate it around. So you can come in and line it up exactly with this cube. I don't know why you would want to do that, but you can. And it is super helpful to be able to do stuff like this. Hopefully this video has helped you understand the power of rendering like this. All of the changes that we made inside of Nuke could have easily have been hours and hours more rendering, rather than just a couple of minutes of work. So as always, if you did find this useful in any way, feel free to leave a like and comment on the video if you have any questions, and don't forget to subscribe. Alright, see you later.